I'm Jim Kelly, as he said, with the Minnesota Department of Health. We've been working closely with the Pollution Control Agency and the DNR and this particular issue of PFAS in the East Metro for, over 15 years. So we've been studying this issue. We're here tonight to kind of share where things are at and how the work that the Health Department does fits in with the overall settlement work that Kirk's going to say a little bit more about later on. So I'm here just to say a little bit about what PFAS is and why we're here. So what are these chemicals? It's a large class of industrial chemicals. They're surfactants, which means they help other things move easily. With unique chemical and physical properties. Some of them are, because of this chemical nature, makes them very persistent in our environment. It takes a lot of energy to make these chemicals, to create them, and so that it takes a lot of energy to break them down again too, and it's more energy that is just typically available in nature. So once they're manufactured by man, nature has a really hard time breaking them down again. They've been used since the 40s in a wide range of consumer products. PFAS was this kind of signature chemical that 3M manufactured that was used in Scotchgard and similar kinds of products, stain repellents, etc. PFOA, which was another chemical manufactured at their Cottage Grove plant, was used to make nonstick coatings. So a lot of that was sold to DuPont and used in the Teflon manufacturing process. Also, as well in some other products where it had the properties of helping make things more stain resistant or waterproof, etc. So these chemicals have had very useful lives. They were very intentionally made for their unique chemical properties, and they worked really well for the applications they were developed for. But these same properties that made them so useful in these applications cause some kind of problems once they get into the environment. And we'll touch on that a little bit more about how that comes into play. Some of the most bioaccumulative and persistent of these chemicals, PFOS and PFOA especially, have been mostly phased out in the Western world. They're still used or manufactured to some degree in other parts of the world, but they've mostly been phased out of production and use here in the United States. So their levels are generally, overall in the environment, are declining, which is good news, but they are in certain pockets where they were manufactured or disposed of, such as we have here, unfortunately, in Washington County, is where we still see this issue. Oops, wrong way. Oh, it wasn't. So we'll talk a little bit about our water guidance that we've developed here at the Department of Health. So why do we do this work? We're charged under the State's Groundwater Protection Act from 1989 to develop criteria for chemicals that are found in our groundwater systems that are used as sources of drinking water. We do this work to help our fellow agencies such as PCA drive cleanup action so that if groundwater has been contaminated, it helps set the benchmark for them to help restore the groundwater to its conditions where it can be used in an unlimited fashion. We're supported in part by Clean Water Land and Legacy funds that's led to the creation of our Contaminants of Emerging Concern initiative, which is the part of the program that I manage that looks at new chemicals, emerging chemicals, of which PFAS may no longer necessarily be emerging, but it certainly was 10 or 15 years ago, very much fit that picture. So as I mentioned, PFOA, PFHXS, and PFAS, three of the chemicals in this family that we found here in the East Metro area, the kind of key issue with them that makes them such a concern is that they are eliminated very slowly from the human body. That is, very low levels in water can build up or accumulate in your blood to where you have levels that might be, if they're part per trillion levels in the water, you can end up with part per billion levels in the blood. Or part per billion levels in the water, you could end up with part per million levels in blood. So they accumulate very easily in the body. It takes your body a long time to accumulate them, just the same way it takes your body a long time to eliminate them. And I think that's an important factor to keep in mind. So it's kind of a long-term exposure that we're concerned with. So having a glass of water that might have something in, low levels of these chemicals in them is not necessarily a concern. It's that consumption on a daily basis over many, many years that starts to drive up those serum levels to levels where we might be concerned. So the guidance values we've developed for these chemicals, the most toxic or accumulative ones, PFOS, PFOA, and PFHXS, were developed based on this idea that the guidance values are based on the idea of trying to protect against excessive transfer of these chemicals from the mother to a developing fetus. We found out fairly early on that they can cross the placenta so that the developing fetus can also build up levels of these chemicals before they're even born. They're also excreted into breast milk, so that is also another pathway that an infant can be exposed right after birth. And because very young infants typically drink a lot of water per their body weight, more than adults, that can build up even faster in very small infants. So we really had to try to take that into account somehow in developing guidance values for the most problematic of this family of chemicals. The goal of it is to keep those accumulated levels in the mom's to-be in her blood low enough so that exposure to of her developing fetus and then her infant are below levels of concern. So that exposure to our very most vulnerable population, that developing fetus and the infant, is really what this is based on. For everybody else, our guidance values are probably overprotective. In fact, we've calculated that they're likely to be overprotective. If you're a guy, it's not, you could probably get by with a lot higher levels because we're not carrying fetuses and passing that on through breast milk. That's just the fact. But we have to protect that most vulnerable of populations. I want to stress that even though breastfeeding is one of the ways that can lead to exposure to these chemicals, we really wanted to stress to the communities out here that breastfeeding is really important for both the short and long-term health of an infant and for the mom both. And we want that practice to continue. I think the benefits far outweigh any small risks that would come from doing those practices or any small levels of contamination that would be passed on. So we want to stress that the benefits in this case likely outweigh the risks, but ultimately we want to protect those moms-to-be so that they don't have levels that would ever be of a concern. One of the questions we get is that if you're looking at the science around these chemicals, many states have developed guidance values along with the EPA, and oftentimes they're all a little bit different. Part of that is because this is a really fast-moving area of research. There's constantly new studies coming out. It's been a very active area. Sometimes we see up to 100 papers coming out in a month in the scientific literature. That's a lot. So it's keeping up with that and figuring out what's going on in the newest studies is critical in this area. Sometimes there's differences due to timing. Methods tend to change over time. And oftentimes the difference is that each state approaches this a little bit differently and might use different factors in the equations that we use to develop water guidance. This slide, again, is kind of busy, but it talks about some of the different factors that can differ between states. There are things like how we look at the studies that we use, the animal studies that we use to derive these guidance values. So things like the NOEL, which is the term we use for the no observed effect level, how you might look at that and calculate that could be different from state to state. Uncertainty factors or safety factors, sometimes we apply them in slightly different ways where one state might use 30, another state might use 10, so you're going to get a slight difference in the value there. Things like the drinking water consumption rate. We again use the drinking water consumption rates for that most vulnerable of our population, the very young infant breastfeeding or bottle feeding. If a state's using an adult intake rate, that's going to result in a slightly different value. So there's multiple different factors that can be just a little bit different, which is why you might say one state having a value of 15 parts per trillion, another one's 13, another one's 12. In our minds as scientists, they're virtually the same number, and these differences, minor differences, are due to variations in some of these factors that we apply. So these are the current guidance values that we have for the PFAS chemicals that we monitor for in the groundwater and drinking water in the East Metro. They vary and range from 7 parts per billion for PFBA. That's a short chain chemical that has a very short half-life in the body. Your body clears that chemical in a matter of days. Versus PFOS or perfluorooctane sulfonate, the one right above it, that number is 15 parts per trillion because it takes your body many, many years to clear that chemical out. That's by and large the largest driving factors in these numbers. So they have a very big range, and that's why the numbers are slightly different based on their properties. We also look at the combination of the chemicals together because they have similar potential effects on the body. They can affect the development of a fetus, obviously, as I mentioned. They can affect the immune system. They can affect the liver and other systems. They all have similar effects. So we look at them if they're present in mixtures in the groundwater, which they often are in the East Metro. We look at the sum total, essentially, of the chemicals in the mixture and compare that to what we call a hazard index, where we take the concentration of each of the chemicals divided by its guidance value, add that up, and if it exceeds 1, it's pretty much the same thing as if one of them individually exceeded a guidance value. So we really try to look at the sum total of the chemicals together, so we're making sure that if there's more than one present, we're providing an adequate margin of safety to prevent exposure above the levels that we might be concerned about. So it's a very cautious approach. We're one of the few states that have this methodology actually promulgated into our rules, so it's gone through a rulemaking process and been reviewed. But we think it's the most prudent and most health protective way to go about this. And I think I'm going to stop there and turn it over to my colleague Ginny Yingling, who's going to talk a little bit about where we've been finding these chemicals and how they've been moving around the environment in the East Metro. So I'll turn it over to Ginny.
Thanks, Jim. Jim said I'll talk a little bit, so that was a clue to me to keep it short, because he knows how I can ramble. So we have been doing a lot of sampling in the East Metro. So we started back in 2003. The Pollution Control Agency came to the Minnesota Department of Health in 2002 and said that 3M had reported to them that they thought they had a problem with the water at their plant, and that made us all concerned that maybe there was a problem with water in other parts of the community. And so our lab quickly set to work to develop analytical methods to test for these compounds. So starting in 2003, we could test for 2 of them, PFOA and PFOS. The detection limits were relatively high, and so we didn't find much when we got going at first. Over the time that we've been doing this work, the detection limits have been incrementally lowered several times, and that's allowed us to find more and more of the contaminants at very low levels down into the part per trillion range these days. So in that time frame, since 2003, we've collected over 13,000 groundwater samples from a variety of wells. Approximately 3,500 wells in the East Metro have been sampled. 76 of those are community wells, like your city water supply wells, and then larger supply wells for places like Eagles Watch Development and the Cimarron Mobile Home Park. 3,200 plus residential and non-community public wells, and those are things like schools, businesses, churches that are on a well, anywhere that the public might be drinking the water, but not on a long-term or a regular basis. So we've sampled quite a number of wells. For drinking water samples, we've got over 10,000 samples. Of those, 1,300 were collected from the community water supplies, and about 8,900 or almost 9,000 from those residential and non-community public water systems. And that's because some of the wells we've sampled more than just once. The city water wells are sampled on a regular basis. The more contaminated of the private wells get sampled regularly, and then we do what we call sentry wells throughout the affected areas to keep an eye on things in the aquifers to see if it's changing over time. Right now, we've been sampling about 1,000 wells a year since 2016, ever since the EPA's new lower lifetime health advisories were issued in May of 2016. We've upped our sampling, and as we've lowered our drinking water advice since 2016, we've continued to do a lot more sampling to try and identify all the wells that may be in exceedance of our guidance values. In that regard, we have well advisories and response actions going on in most of the affected communities. Oakdale, Woodbury, Cottage Grove, Lake Elmo, and St. Paul Park all have one or more city wells that have received advisories from the health department because of exceedances of our guidance values. And in each case, they've taken some action to address that. The cities that have more wells are able to shut off some of the wells or use them on a very limited basis and rely on flow control, using the cleaner wells and then only using the more contaminated ones when they absolutely have to, but keeping the overall concentration below our guidance values. Other cities like Oakdale, Cottage Grove, St. Paul Park are in the process of, have either installed carbon filtration systems or in the process of doing so. And both Oakdale and Cottage Grove and Lake Elmo have also either installed new wells or are in the process of doing so, and installing those in areas that are not contaminated. In terms of the residential and non-community public wells, we've issued over 1,250 drinking water advisories for those systems. The state, through the Pollution Control Agency and their emergency response system, as well as under a consent agreement with 3M that funds this work, they provide bottled water as an interim measure, and then install either a whole house carbon filtration system, a granular activated carbon system, or they can, where it's possible, they connect people to city water. So that's occurred in Lake Elmo and Lakeland and Lakeland Shores. This map gives you sort of a cartoon version of what's going on, kind of the big picture. As Jim mentioned, this has been going on for a long time. There were 3 major disposal sites in the East Metro, and it's a little hard to see, but the little flags show where they're located. So there was, I don't know, do I get an arrow? Does that show up? Nope. Do we have a laser pointer? I've got a pen, but that doesn't help. All right, well, be as it may, there were 2 major disposal sites north of Woodbury, one in Oakdale. It was a large dump that was in a wetland area just to the west of the Menards off of 694, so you probably are familiar with that. The other was the Washington County landfill up in Lake Elmo, just south of Lake Jane. PFAS-bearing wastes from 3M were disposed of in those landfills, as well as the Woodbury disposal site right on the border of Cottage Grove and Woodbury, along Woodbury Drive or Keats Avenue. And then there's also been there was some waste disposed of on site at the Cottage Grove plant itself, but that from there, it just goes straight out to the river, the stuff that infiltrated there. All 3 of those sites, the contaminants quickly went to the groundwater because none of those were lined landfills. Back then, we didn't line our landfills, unfortunately. And so very rapidly, these plumes probably established because these chemicals are water soluble and very mobile in the environment. So it's likely that these plumes established very quickly, starting in the late 40s, early 50s, and through the 60s and into the early 70s, at which time all of the sites were investigated because of industrial solvents that were being detected in people's water supply wells. And so site investigations and cleanups occurred at all 3 sites that started to reduce the amount of contaminants that were in the source areas, and as well as putting in control systems, groundwater extraction systems, to try and contain the contaminants on site, pull them out, treat them, and discharge them. The problem was we didn't know the PFAS chemicals were in there, and a lot of the treatment options did not address those chemicals. And so basically we pulled them out of the ground and sent them on their way. So the other thing to note here is that we've got 2 major drainage features in this area. There's the Mississippi River on the west and south of the county, and then the St. Croix River on the east side. All the groundwater in Washington County is going to discharge to one of those surface features. And there's a divide that runs essentially north-south that cuts the county in half that determines which way the groundwater flows. On the east half, groundwater flows east-southeast towards the St. Croix, so I put a big blue arrow directed that way. And on the west side, there's the water flows south-southwest towards the Mississippi River, so again, an arrow. And you can see the areas that are shown in green, which is PFOA, and black hash marking, which is PFOS. You can see that they're kind of following those trends, depending on which side of the divide they're on. The brown area is PFBA, the one that Jim mentioned, that's so water soluble. It's a small molecule. It doesn't like to stick to things like some of the other chemicals do. So once it's in the water, it takes off and it goes a long way. We also think there was probably airborne deposition of PFBA from the plant and also from other sources, because no matter where we sample in Minnesota, we will find some PFBA in groundwater at some trace level, 10, 20, 50 parts per trillion, no matter where we sample. So it's a very common contaminant, unfortunately, in the environment. The thing that's unusual, and it doesn't really affect Woodbury too much, but I know there are folks here from other communities, is how did we get all that contamination in West Lakeland Township if all the sites are on the west side of that groundwater divide and everything should have been going to the river? And the reason for that is there was an interconnected stormwater system that I'll show you in a second that helped move it across that groundwater divide and into West Lakeland Township. The other thing that's on this map are white dots that show all the wells that we've sampled over time to give you a sense that we have looked across the affected communities. And then the purple dots are where we have well advisories, and you can see how they cluster essentially wherever we have PFOA and PFOS. That's what's driving the drinking water advisories, are those two chemicals, because of the very low guidance values that we've set that Jim talked about. So when we look at the actual maps of PFOA on the left and PFOS on the right, this gives you a sense of the concentration trends within those plumes and where the high concentrations are in the reds, the darker reds and oranges, all the way out to yellow. Anything from yellow, orange, or red, those exceed that chemical's individual guidance value. So you can see the large areas up in Oakdale, Lake Elmo, West Lakeland Township, and then parts of Cottage Grove, where we've got concentrations of PFOA that exceed, and then only up in Oakdale, Lake Elmo, West Lakeland Township, and a little bit of Woodbury, and then a very small part of Cottage Grove, way down near the plant, do we have PFOS that exceeds our guidance values out in the residential wells. And again, that's partly because PFOS is slightly less soluble, slightly less mobile than PFOA, so it doesn't go as far. It also was at lower concentrations in two of the disposal sites, especially the Washington County landfill in Lake Elmo. There was hardly any. By the time 3M was disposing of waste in that facility, they had shifted their chemistry primarily over towards the PFOA side of things, and so there's very little PFOS in there. And yet you can see down gradient, or southwest of the Lake or the Washington County landfill, we've got high levels of PFOS. And that's what put us on to this surface water system that has spread the contamination across the groundwater divide. There's a creek that flows out of the wetlands at the Oakdale disposal site. It is contaminated with PFOS, PFOA, and the other chemicals. There was also a groundwater extraction system at the landfill that went into a stormwater system that flowed into that creek for about a period of 7 years, that because we didn't know the PFAS was in the water at the time, it seemed like a reasonable place to discharge the pump out water, but it ultimately was not. But then in the late 80s, early 90s, the Watershed District, in an attempt to control flooding on a number of the lakes in the Lake Elmo area, and protect Lake Elmo, which is a high-resource recreational lake, from stormwater inputs, they created an interconnected stormwater system. And this map is showing you with the dark blue arrows being surface water or stormwater, and the light blue arrows being groundwater movement of the chemicals. That interconnected system eventually brought the contaminated water from the Oakdale and the Washington County landfill sites into Eagle Point Lake, across Lake Elmo, into West Lakeland through Horseshoe Lake, and then it's infiltrating throughout the course of a series of stormwater ponds and ditches and created a large area of contamination that's now moving out to the St. Croix River. So you can see all the infiltration as the blue arrows as it's moving along, and that's why we are now spending so much time in West Lakeland Township trying to identify all the homes that are affected there. And that gets me to sampling priorities. Out on the table, and I know some of you filled out forms, we've got some yellow forms. If you have a private well, and you're within the affected areas, basically the areas shown in brown, we'll be glad to sample your well and test it for PFAS. But we do have some priorities because we want to focus on people who may be the most highly exposed. And so our highest priorities are wells that are in or down gradient of the areas that have PFOS and PFOA and have not yet been sampled. Wells that are near those areas because we want to be sure we have defined the edges and have good buffers around the plumes. And then we want to resample wells that have the health risk index that Jim mentioned, that additive value. If it's greater than 0.75, we want to get those resampled. That's our top priority. Next is to resample wells with a health risk index of over 0.5. Resample any wells that have any PFOS or PFOA detections. And then a little lower on our list, we'll still get to them, but testing wells that are in those lower priority areas or testing people's filtered water if they have a filter system they installed or if they have a filter system that the state has installed.